Bismillahirrahmanirrahim. Assalamualaikum and very good morning. So today we'll be discussing about ceramic processing. As for some introduction for ceramic processing, and we'll be going to discuss about powder synthesis, powder preparation and processing, powder consolidation forming, thermal treatment, and the finishing. So this is the learning outcome of our class today. At the end of the class, you should be able to list the basic step in ceramic processing, explain the theories involved in synthesis of powder, uh, compare and contrast the various techniques in producing final products of ceramic. And then you are expected to be able to list the sintering and types of sintering and explain the mechanism of sintering. All right. Normally, ceramics are originated from the form of powder. So this is the key start of processing of ceramic. So the powder synthesis is one of the main agenda in producing the ceramic. It has a large influence on the final properties of ceramic materials, and definitely the ceramic products are made of agglomeration of particles. So this particle can be oxide, hydroxide, carbonates, and nitrites. Particles and other ingredients such as binder and lubricants may be blended wet or dry. And techniques of powder synthesis includes chemical precipitation and calcination. One of the example. What is chemical precipitation and chemical calcination? So this process are very common for production of ceramic powders because high purity is highly needed to obtain the salt that can be decomposed into desired oxide compound. So common salt used is hydroxide, carbonates, nitrates, and sulfate. Precipitation of desired salt derived from the chemically reaction of water-based solution. And final step is the thermal decomposition of the salt to desired oxide. We call it calcination. This is an example of the figure that how we can understand about the chemical precipitation. The formation of the separable solid substance from a solid either by converting the substance into an insoluble form or by changing the composition of the solvent to diminish the solubility of the substance. If you can see the figure, there's a solution, and after sometimes we can see that there is a suspension, supernatant, and precipitate. So those are by chemical precipitation. Okay. So this is an example. Basically, it's solid that forms out of solution. A common example is the mixing of two clear silver nitrate. So we have a silver nitrate. We mix it sodium chloride, and the reaction is shown in the slide. So the precipitate forms because of the solid of the silver chloride is insoluble in water. So if it is insoluble in water, this is true for all precipitates, and the solids are insoluble in aqueous solution. So you can see from the figure that we can observe in the yellow area. Right, this is an example. I think this research has been done by Rabdul Adawiyah, our lecturer in materials technology. So there is a pandan leaf aqueous extract, mixture of pandan extract and sodium silver nitrate after 5 minutes incubation, after 10 minutes, and after we complete the conversion. So that is the precipitate we have obtained from the experiment. This is a very simple one. And then for calcination, it's a thermal treatment process in the absence of air to solid materials to bring out the thermal decomposition phase transition or removal of the solid volatile fraction. So the calcination process normally takes place at room temperature. It depends on what we want, but it should be below the melting temperature, melting point of the materials under investigation. So the purpose of calcination is, number one, is to provide additional drying, vaporize or decompose organic additive and other impurities, and remove residual crystalline and chemical bound water. All right, some powder preparation and processing ceramic requirements are usually much greater for a new ceramic than for traditional ceramic, definitely, because traditional ceramic, as you know, that we have the, for instance, labu sayang and etc. So improvement needs to be ventured to ensure that we will be getting some higher strength of materials. Therefore, the setting powder must be smaller and more uniform. This is a key word. Okay, the uniformity and the size of the setting powder must be as low as possible, as small as possible, since the strength of the resulting ceramic is inversely related to the grain size. Okay, greater control of the starting powder is required. Powder preparation includes mechanical and chemical method. So there is another type of process, you see comminution, which is reducing particle size in ceramic processing by use of chemical energy in various forms such as impact, compression, and attrition. Comminution techniques are most effective on brittles such as cement, metallic ores, and brittle metals. So the types of comminution includes crushing and grinding. So this is an example and how you can see that the crushing process and grinding process takes place. Okay, further details is in the slide. Okay, I think as for now we stop it here. I will continue the recording after. Thank you.